Hello everyone, welcome back to OnPrep, and today we are discussing one of the important system design interview concept, which is metrics monitoring and alerting system. This is one of the most widely asked topic in the system design interview, and this is another addition to my video playlist on system design interview on software engineers targeting for a role for staff software engineer to principal software engineer. And as we know, the typical time duration for this interview is around 45 minutes to 60 minutes. If you have not watched my step-by-step approach on system design interview, I would highly recommend for you to watch that video. It will help you to understand the step-by-step approach. It will help you to understand the format of the system design interview and how you can go over in a step-by-step approach considering the time on each of the step you should spend. Let's start with step 1, which is understanding the core functionalities of the system. This is a infrastructure related problem statement where we do not have a user facing interfaces. So our main focus would be on the core functionality, implementations and a working solution end to end, and we go deep dive for scaling the system for thousands of, and we will less focus on the APIs and the schema design as we do not have the user facing interfaces. We would like to make sure that the internal implementation of the solutions work end to end while satisfying the core functionalities of the system. So what does this system does? Let's start with the core functionality of the system. Metrics monitoring system is something which we already discussed in our previous system design interviews as part of the operational excellency, where we wanted to monitor the performance of our system which we have designed. But specific to this discussion, we wanted to focus on the monitoring the performance of the servers. So you can imagine there are hundreds and thousands of servers. So you can imagine there are hundreds and thousands of servers hosted on an on-premises infrastructure on which services are deployed for serving the REST APIs or user request. But we do not want to focus on those services. We only want to focus on the performance of those servers, and resources belongs on those servers like CPU, RAM, disk, network. Now, why do we want to monitor the resources on those servers? The answer is we wanted to scale our infrastructure if, let's say, the servers are overly occupied serving some of the requests and the CPU utilizations and RAM is very high. So we can scale out the server by adding more servers into the infrastructure, or if the resources are underutilized and these servers are free, so we can scale in by removing the servers from the infrastructure, which will help to reduce the capital expenditures. This is about metrics monitoring on this infrastructure. Coming to alerting system, why do we need to alert the system in case of any server failure or if the CPU RAM threshold is reached? We wanted to send the notifications to the business team, developers or support team so that the relevant stakeholders can act upon it on maintenance of this infrastructure. So let's start with the step 1, which is functional requirement of the system. Collect the data or events like CPU, RAM, available disk storage, etc. Once we have this information, then we wanted to store this information for displaying on the dashboard or creating the alerts. These are the core functionalities of the system that it must support. So we can collect these events for each of these servers hosted in the infrastructure, store these information in some storage, provide a dashboard for the stakeholders to look at the performance of these servers, and when there is a threshold reached for RAM CPU utilizations which needs the intervention from these stakeholders, we can create the alerts based on the rules defined by these users. So let me add the rules as well. Create, update the rules for these alerts. Considering the non-functional requirement of the system, as I always recommend to start talking about the latency and the cap theorem required for such a large system. So we need low latency on loading the dashboard. And about cap theorem, as we are having the distributed system, we need high availability over consistency for this dashboard. What does that mean is, what kind of dashboard it would be. Let's say this is the graph we are showing in the dashboard, and we are talking about the CPU utilization for a specific server. So the graph would look like this with respect to the time. So for the first second, we are having CPU utilization of, let's say, 10%, and on fifth second we will have a CPU utilization, let's say, of 20%. So this is a graph what we are showing in the dashboard, and we would like to prioritize availability for this graph over consistency. That means if there are any delays on showing the most recent information in this graph, it's okay to have some delay instead of not showing this graph at all. So we wanted to prioritize to show this graph as quick as possible, even if we wanted to compromise on having some delays of milliseconds on showing these matrix information into this graph. Talking about the read and write request into this system, let's say we are having thousands of servers on which we need to collect these metrics every. Now the frequency of these metrics collections depend upon us and how do we want it to propose to start with. Let's say for these thousands of servers collecting matrices every milliseconds. Now you can see this would be very high number if we are collecting, let's say, these three metrics like CPU, RAM and disk every millisecond on these thousands of server. Maybe you can get into the calculations, but that's not we wanted to focus on in the beginning. You need to have this clarification with the interviewer if you wanted to calculate the number of reads and writes and how much data storage you would need for 5 years or next 10 years. To understand more on this, you can watch my previous videos on Book My Show, where I have talked in detail about number of requests for read write and how to calculate the storage you would need for next or 10 years. As I always suggest to check with the interviewer if you really need to do this calculation. Probably that would not be the focus of this interview, because at the end of the calculation you would understand that you need a distributed system, that your single instance of the server would not be able to serve the request within the given SLAs, and you would need to partition the data. For this kind of such a large system where either the data might not be able to fit into the single instance of the machine serving for next 10 years, or your read and write requests are so high that for a single instance of server would not be able to read or write within that given SLA. So at high level, we will talk about the cap theorem here if we need to partition the data, and the performance of the system by discussing the latency, and we move forward. So what kind of input data we have in our system? We have the events like CPU, RAM and disk utilizations that we wanted to store in our system. So we can have name, like what is the name of this event. It could be a CPU or it could be RAM. What is the value at given time? Value we can represent in terms of percentage. So let's say we have 0.58, which would be the 58 percentage utilization. What is the source of this data? We can have the host name or the IP address of the server. And another important attribute is the timestamp. Now this timestamp we can represent in a form of a epoch. 4, 5, 6, 7, 8, 9, 2, 3. Spock is the number of milliseconds elapsed from 1st January 1970. Let me move this on the left. And the next step is the API design. To start with, we can begin with a simple get REST API, which is API for the dashboard, where we will have the search query like the name of the matrix which we are interested on and the time from and to, and the source. This is a simple get API for the search query in our dashboard, and you can understand that this is a pull based. So when the dashboard is launched, it will query to a service to load these metrics and display in a form of a graph. But we also need to talk about how this dashboard would be updated at real time. We can have the short polling or long polling APIs, or we can establish the web socket connections as well, which will keep the dashboard updated. But that would be too much in the beginning, and we can get into when we talk about in more detail in our deep dive. We also want to talk about the APIs for creating the alerts and how these alerts will be triggering when a specific threshold has been reached for CPU or RAM on a specific server. But let's park that as part of the deep dive and check with the interviewer if he or she is really interested to talk on all those areas in detail, right, as part of the API design or as part of the system design in deep dive.